Hi guys, I'm Darsh. Do you want me to just get started? Do you want me to share my screen?
Go ahead.
All right. Okay, give me a second. All right. Can you guys see my presentation?
Yes. Yep.
Okay. So hi everyone, I'm Darsh. I am a rising junior at Jesuit High School. I'm going to talk a little bit about my journey with AI, talk about AI in general, and then talk a little bit more about like the specific, sort of the specific tools you can use in AI and what you can use it for, and also talk about some of the projects I've done. Give me a sec. All right, so a little bit about me. I'm super interested in scientific research, particularly in bioinformatics, which is sort of the overlap of computer science and biology, using computer science to solve biological problems. And I'll talk a little bit more about that a little bit down the road. I'm also super interested in the humanities, stuff like linguistics and history. That's all really interesting to me. And there's ways you can apply AI to those fields as well. And like social justice and climate justice and justice in general is also super important to me. And so there's ways to work that into AI as well. And I'm excited to talk to everybody a little bit about this. So more on my journey with research overall. I got interested in scientific research when I was in first grade. I joined my elementary school science fair, and I did this little project with, I built a little model that has like a tinfoil ball, and I wanted to measure the static electricity of different fabrics. And I thought that was really cool when I was in first grade. And that's kind of how I got into research. And since then, I've participated in the science fair every single year. A little bit down the road, when I was in fifth grade, I got really interested in cancer because a few years prior, my grandfather had been diagnosed with cancer, and I got really interested in what cancer really is on a biological level, what its molecular biology is like, and what causes cancer, and like how it's being treated and stuff like that. And over the next few years, I kept reading more about cancer and learning more and more about cancer in general. And when I was in seventh grade, I started seeking out mentorship to learn more about that. And I'm really thankful that Dr. Ritz, who is a professor, an associate professor at Reed College of Biology, I'm really thankful for her mentorship. I've had her mentorship for a few years. And she introduced me to the field of bioinformatics, which I mentioned on the previous slide. Bioinformatics is applying computer science to biology. And I got really interested in that. And I got interested in how we can use AI to solve problems with cancer and cancer treatment. And so I ended up getting started on my very first project, which was using AI to predict drugs for cancer patients using genetic mutations. And over the next few years, I started doing more similar projects in the same field, using different predictive methods different predictive factors like microRNA, and also combining different predictive factors together using multi-omics. And we'll talk a little bit more about these projects. So a little more on my very first project. I'll give you guys some more background information too. Cancer, what I've learned is cancer is caused by genetic mutations that can result in uncontrolled cell growth. Basically, these mutations stop your cells from performing programmed cell death. And now they just keep growing and growing bigger and bigger. And that's what forms tumors. And treating cancer is a major challenge for oncologists who are cancer doctors because cancer is extremely heterogeneous. And so different patients, if you have two different patients, their cancers are going to be very, very different. And unfortunately, the current method of treating cancer is a very generalized approach where patients with the same type and stage of cancer usually receive the same treatment, and they go through a bunch of different treatments before the right one works for a patient. This is a really time-consuming process, and that's really problematic. So one of the things we're focused on now is precision medicine, which aims to prescribe the right drug and treat a patient based on their own very personal biological data. And so this is where AI comes in, because AI can be used to analyze large volumes of data and make predictions based on that. So I decided I wanted to use machine learning, which is a branch of AI, and use that to make predictions for a cancer patient based on their mutations, make a prediction of which drug is going to work the best on them. And I was able to do this successfully, but I decided to continue down that path and do even better. And so I decided to look into microRNA in my next project. And this is another biological factor. MicroRNA can offer like better prediction than just using genetic mutations. And that's why I wanted to dive into microRNA. A little bit on the biology side, the way microRNA, well, the role of microRNA is to regulate the process of gene expression. And so when you have something wrong with your microRNA, this means the process of gene expression can become dysregulated. And again, that leads to your cells growing uncontrollably, causing cancer. So I wanted to zoom in on microRNA and study how I can use AI to predict drugs for cancer patients based on their microRNA. And this time I expanded it to use 23 different cancer types. And I was able to achieve a better accuracy than I had with my previous project of about 76%. And now my most recent project, which I'll dive deep into this project and talk to you about all the steps and stuff. What this project did was multi-omics. And what that essentially means is using multiple biological factors together. And I basically combined the microRNA and the genetic mutations, and I use them together to predict drugs for cancer patients. And again, I used 23 different cancer types, and I got an even better accuracy than I had before. So I guess this kind of highlights my journey throughout research for the past few years, how I've built on what I've done in the past. And that's really key if you're doing any kind of scientific research, building on your own previous knowledge and the past knowledge of other researchers. So I'll dive more into this most recent project now. This was my research goal or my research question. I wanted to use machine learning, again, a branch of AI, to predict the right drug to give to a cancer patient based on their multi-omics data, combining both microRNA and genetic mutations. So now this is an overview of, I guess, sort of a pipeline that you can use if you're doing an AI project. And this can be, I'm going to talk about this from the perspective of my project, but you can really use this general layout for any kind of project that you're doing using artificial intelligence. My first step was to gather data. This was, of course, you need to make predictions based on data. So I got data online and I wrangled that data, which means getting it into the right format that I need, and also extracting the relevant information I need. A fundamental thing in AI was my next step, which is splitting my data up into two parts, 80% for training and 20% for testing. As Rishabh mentioned earlier, with AI, you're training your computer and your program to learn. And that training data, the 80%, is where your program learns to analyze patterns and figure stuff out. And then the testing data remains unseen so it can test itself and make sure it's making good, accurate predictions. I also conducted feature selection, which allowed me to select the most important genes and microRNAs. And I'll get more into each of these steps in the next slide. And so once I'd done that, I trained my program on that 80% using a few different machine learning algorithms. And then I conducted cross-validation, which allowed me to further train my model. And I was able to finally create a program that can predict drugs based on a patient's biological data. And I know that I threw a bunch of words at you guys, so I'll talk a little bit more about each of these steps now. So that first one, after I was done with all of my data, feature selection was the first thing I did. And what feature selection allowed me to do was it allowed me to focus in on the genes and microRNAs that were actually having the greatest impact on my final drug prediction. That way I don't have like too much noise in my data. And so I actually went from like 18,000 different genes and microRNAs down to just 945 key biological factors. And there were different algorithms you can use for this, and I ended up using the extra trees classifier in Python. So these are, I'll talk a little bit more about the algorithms I use for the actual prediction, and I think some of these are really cool. The first one that I tried was a decision tree, which is kind of just like a flow chart. So it's really simple when you think about it. It's just a flow chart that asks a series of questions about a patient's biological data. And based on those questions, it makes a final drug prediction. There's also the k-nearest neighbors classifier, as well as a couple other algorithms that I tried out. These last two, the AdaBoost classifier and the one versus rest classifier, are called ensemble learning methods. And again, I think this is something that's really, really cool in AI. What these ensemble learning methods do is they combine multiple weak algorithms together and they form a single stronger algorithm. And that allows you to boost your accuracy of your prediction. And I ended up getting the best accuracy with one of these ensemble learners, the one versus rest classifier, at about 63%. And I also did cross-validation to improve my accuracy. Now, what cross-validation is it allows you to further train your model on that 80% in that first stage that I was talking about. And it also allows you to select hyperparameters, which is also something that's really cool about AI. Hyperparameters are like little fine-tuning that your computer can do to get even more accurate predictions. So I did cross-validation using two different algorithms together, and I improved my final prediction accuracy to 81%. Excuse me. Yeah, so overall, with my project, I was able to improve the accuracy of cancer drug prediction. And I'm also able to predict a wide range of drugs using multiple biomarkers together. And so again, this goes back to my journey throughout research with how I've improved over time based on what I did at the very beginning. Yeah, so this is my project overall, but I just want to say that you can use AI for whatever you want to pursue. At the end of the day, AI is just a tool that you can use to answer questions and make predictions. I know AI can be used for things like archaeology and linguistics. So what I want you to do is go out and find your passion. And once you find your passion, figure out what question you want to ask and use AI to solve that problem. Thanks, and I am done, and I'm definitely open to answer any questions you guys have.
Yeah, it looks like we have a question in the chat. What are the challenges you faced in your project?
Yeah, so there's definitely quite a few. Sorry, one sec. So yeah, there's definitely a few challenges that I faced, especially with my accuracy. So getting a good accuracy was a key challenge. And so I ended up having to test 4 different algorithms that I talked about. So that was one of the challenges, and also fine-tuning my model to make even more accurate predictions was also a key challenge.
Thank you. I was also wondering, did you use supervised or unsupervised learning in your project?
Yeah, so I use supervised learning. Unsupervised learning is usually used for unlabeled data and putting them into unlabeled groups. In my case, I had labeled data, which were patients, and I wanted to put them into labeled groups, which were like different drugs that they could use. And so I used supervised learning methods for that.
Nice. I was also wondering, what advice would you have for anyone here who would want to work on machine learning projects in biology?
Yeah, so in biology in particular, basically what Rishabh mentioned, go out and do a lot of reading with literature that's published. See what kind of problems there are. Find out problems that you're really passionate about and problems that you want to solve. And I guess that applies to outside of biology too, because you don't have to be interested in biology to use AI. You can do it in whatever field you want to pursue. So just go out and read literature, figure out what problems exist, and see which problems you want to solve.
Thank you.
Yeah, thanks for having me.
Any other questions, they can put them in the chat. Oh, I was also wondering, what do you have planned for the future? Like, what's next?
I don't really know. I'm gonna think a lot over the summer, do a lot of reading with literature, and start probably working on a new project in the fall or maybe even in the summer if I can come up with something.
Nice. Thank you so much.
Yeah, thanks for having me.